Okay, question for 2018 AP statistics. Remember, actual tests. These are real life questions. The first three questions are all things that we did in class, but guess what? Number four, we haven't done it yet. But I'm going to present this question in a way that shows you, hey, if you got the format with the hypothesis test and the confidence interval down, and you know where to look on the calculator, you can still get the answer. All right, here we go. I posted the question. It's number 4, and here we go. The ACL is one of the ligaments that help stabilize the knee. Surgery is often recommended if the ACL is completely torn, and recovery time from surgery can be lengthy. A medical center developed a new surgical procedure designed to reduce the average recovery time from the surgery. To test the effectiveness of the new procedure, a study was conducted in which 210 patients needing surgery to repair a torn ACL were randomly assigned to receive either the standard procedure or the new procedure. Okay, let's stop and just talk a minute about what we have here. Last September, lesson 1, I told you all things broke down into two types, two categories, or one of them is categories, but two categories of data: categorical data, quantitative data. Categorical is the P, quantitative is the mean or mu. All right. So everything we've done in inference so far, today being April 28th, whatever it is, has been to the proportion, but soon we're going to have to transition to means. And with means come a different distribution, and it's called a T distribution. Now, I will talk about this more in class. All I will say right now is a Z for proportions always stays the same. But a T distribution, depending on the sample size, morphs with low sample size has fat tails, high sample size becomes more and more normal. I know that probably sounds confusing, but still, if you follow me, you could get this question right, not knowing that. Okay, so if you look at the box, we have a bunch of data. These are the things that I would have had to recognize to be able to do this. Number 1, we're talking about a difference of two means, which is the standard and the new procedure. You would have had to know that and known we're talking about means. Okay, the fact that I know that, the difference between two means, I get my calculator, I go to stat and over to tests. Now I'm looking for something that is two sample T, not Z. We're doing means, two sample T test. And I think if you look at number 4, you will see it. So hit enter and you see all kinds of input. There's 6 inputs. Number 1 is the sample size, number 2 is the mean, and number 3 is the standard deviation. So let's do that. I'll do it. You can do it with me as I do it. I look at standard size. I will call that mean 1, okay? Standard size. So it asks for the X bar, which is the mean, and I'm going to put 217 in there. And then it asks for the standard deviation, and I'm going to put 34 in there. And it asks for the sample size, N, and I'm going to put 110. Okay, so far. Now, does it matter which one is sample 1 or sample 2? It doesn't, but you have to keep them straight because the results, depending on them being positive or negative, makes sense. So we're going to put it just as we see it on this problem, okay? How about sample size 2? not sample size, sample 2, which is the new procedure. It is 186. You put that under mean. You put 29 on the standard deviation and 100 under sample size. Okay, now it asks you greater than, less than, or not equal to. Now this is key, but this is hard, so you got to list, or not hard, but a little confusing. So look, standard was number 1, new is number 2. So if we are subtracting the 2, we want the result to be greater than, because we are looking for a lessening of time. So if you wrote that down, it probably would be clearer to you. But we're hoping that this new method is faster or shorter. Okay, so that would make the first one greater than. Now it also says pooled. Are you pooling your data? And you respond yes to that. Okay, you would have had to reason the thing out with the greater than or less than, but you still get a p-value. Where we're headed towards is that p-value, which is really important. So I go down to calculate, and I get a t-value of 7.07. Now, just like a z, a t, if you get something 7.07, in other words, 7 standard deviations from the mean, that is way out there. In other words, from our lesson the other day, very, very unlikely to happen. This sample is very unlikely. There's definitely something going on here. So keeping all that in mind, I haven't even read a question yet, but that's what you do for means. So let's go to the questions now. It says, A, based on the design of the study, would a statistically significant result allow the medical center to conclude that the new procedure causes a reduction in recovery time compared to the standard procedure for patients similar to those in the study? Explain your answer. Now, if you subtract the first one, the second one from the first one, and you get a really small answer, you know that it is greater than. It's greater than that. The first one is greater than the second one. All right, greater than the second one. Okay. Remember, we haven't gone over this yet, but you still can do it. We can do it because if you look, question 1 says, is there a statistically significant? Now, what I want to say to you now is if you have 2 groups, we have here the standard and the new, and we're looking to see if there is a difference between the 2. The same idea is when the P is low, reject HO. And in a, I think that's the next question, but I haven't checked for sure, but I looked quickly. With a difference of means, the null hypothesis would be mu of, I would call it maybe S minus mu of N new would equal to 0, meaning there is no difference. That would be the null hypothesis. And the alternative hypothesis would either be less than, greater than, or not equal to. Now, I've already told you when you're doing the new, the old minus the new, it would be greater than if there's a difference. Because would you agree that if there was a statistically significant difference, the standard procedure would take a larger amount of days, and and the new procedure would be a less amount of days. Therefore, it would be greater. So back to the question again is, does it have a statistically significant difference? We've had a big build-up. This one's been kind of hard to do because you haven't gone over it yet, but I wanted to say I went over all the questions. So if you look at the p-value on our calculator here, I don't know if you got the same, but it is 1.13 e to the negative 11th power. That is an incredibly small number, incredibly small number. So therefore, getting back to the decision we talked about the other day, when P is low, reject HO. And I just said that HO is, let me write that up there actually. HO mu of standard minus mu of new is equal to 0, meaning there is no difference. Alternative, meaning if there is a difference, we're going to say the mu of standard minus the mu of new is greater than 0, meaning there is more days with the standard than there is with the new. Okay, so if I reject that, which I did, I rejected because P was so low, I rejected it. I am accepting the alternative that the standard procedure takes longer than the new procedure, which is kind of weird in thinking at that the new one is less, but you want less here. That's what you want, which makes the question a little bit confusing because we want less. We want less days. Okay, I think that covers question A. Is okay. It is. There is definitely a statistically significant difference favoring the new procedure. Okay, B says summary statistics on the we saw those down below. Do the data provide convincing statistical evidence that those who receive the new, hold on. I thought I was actually answering B with what I just said. Let me see A again. Based on the design, would it be allowed them to conclude? I'm going to consult here our answers because Part B, what I just got done doing for you is the answer for Part B. You put all the data in the calculator and get that really small p-value. Now I'm going to read question A again. It said, based on the design of the study, would it be statistically allow the medical to conclude that a new procedure causes a reduction? I think this might just be about causation and an experiment. With an experiment, there is causation. You know what? I'm going to read the end. I'm going to break a rule. Well, it's not a big rule, but I'm going to actually read what they have first time out today. It said, yes, it would be reasonable to conclude that new procedure causes a reduction in recovery time for patients similar to those in the study. The patients in the study were randomly assigned into two. All right, remember, random into two groups you need for a scientific experiment. That's what they're looking for. Is this a well-designed experiment? Which reduces the chances of confounding variables. What would be a confounding variable in recovery? I know this just from what I know without any AP statistics. What would be another factor? With health, what is always another factor? Genetic, how are your genes? And some people just recover from things, no matter how good the treatment is. Genetics would be a factor. So I think that might be a way. So a well-run, the answer to A would be yes. A well-run experiment that was randomly, that the patients were randomly placed, and that you have at least two groups, the old, the standard, and the new, would say yes, that is fine. Okay, this one was rather lengthy. It had new material. I'm hoping it will be a benefit. The main reason why I went through and did this one is to show you that even if you had not even heard about this question, by being able to identify the right test on the calculator under stat tests, a 2-sample t-test, you got a fighting chance to get this one right. So that is it for this question, number 4. I did the whole thing in one video. Hopefully you stayed tuned for the whole thing. Bye.